Hello guys, I'm back to do 3.2 for this video. I hope you remember 3.1 very well because it continues from 3.2 continues from 3.1. So 3.2 read as follows: sketch a velocity time graph for a ball A. Show the following on the graph. Okay, so this is how you plot your velocity time graph. You first draw your y-axis and your x-axis. So it says you must show initial velocity, of which they gave us initial velocity of 16. So initially it goes upward. Remember, they told us to take the ground as zero reference, so you must show that in your graph as well. So it starts from this is velocity time graph, right? You must also show that, or otherwise you lose all your marks here. So it says this is negative 16 and this is positive 16 meters per second. So it first goes upward, right? So as it goes upward, it's gonna be losing velocity, right? And then until it comes to zero, right? So as it goes downwards, it's gonna be gaining velocity until it comes to 16 again. So guys, this is how you draw your velocity time graph. I hope you can see very carefully. It's always a straight line, always a straight line. So I hope you saw, and remember to write a velocity in meters per second and to write time in second, so you can get your full marks. So let's go to 3.3 very quickly. Another statement read as 1 second after ball A is projected upward, a second ball B is thrown vertically downward at a velocity of 9 meters per second from a balcony 30 meters above the ground. Refer to the diagram below. Okay guys, the question says calculate how high above the ground ball A will be at the instant the two balls pass each other. And you see, this question is very challenging because it gives you 6 marks. Imagine that. You don't want to lose these marks in your matrix, because if you lose these marks, there are few chances of you getting the A in the paper. I know you guys want to get A's and go to good universities, so let me do this one for you. 3.3, right? So it says calculate how high above the ground ball A will be at the instant the two balls pass each other. Remember, they're asking you about ball A, the position of ball A. But if you look, the position of ball A will be the same as the position of ball B, because they will be passing each other. So you must understand your English for you to get that statement. So at that time, y for ball A will be equal to y for ball B. The height for ball A will be equal with the height for ball B. But there's another statement you need to take note here. It says the 1 second after ball A is projected. So 1 second after ball A is projected, a second ball B is projected 1 second after ball A is projected. So B is actually projected at t minus 1. So this is the time for ball B. It's t minus 1, which represented it was projected 1 second later. A second ball B is thrown vertically upward at a velocity it's thrown vertically downwards, I meant, at a velocity 9 meters per second from a balcony 30 meters above the ground. Refer to the ground. Calculate how high. Okay, so here's the equation that's most of the time you must use when you come across this equation like this. So you use delta y is equal to vi delta t plus half of g delta t squared. Okay, so let's calculate for ball A first. Ball A is always easy to calculate. So ball A comes from your final for ball A is y itself, and then your initial is 0 because it comes from the ground. So and then your initial velocity is 16 and it goes upward. We're taking upward as positive, remember guys, that's why we leave 16 as just 16. So delta t we don't know, so we'll just put it as delta t plus, let's just put it as t guys. So and then minus half of 9.8, it's gonna be 4.9 guys. I hope you got that one right. So and then it's gonna be t squared. So y for ball B is equal to 16 t minus 4.9 t squared. So I think this is our equation 1. I think we're gonna use simultaneous equation here in the end. So okay, now let's calculate y for ball B. This is a challenging one. So you still use the same equation, delta y is equal to vi delta t plus half of g delta t squared. So the final velocity of this ball will be y, right? And the initial velocity is 30 minus, the initial position, not velocity, guys. Understand that was a mistake. So and then your initial velocity, it's 9, but it goes downward, so it is minus 9 times, I remember your time for this ball is t minus 1. And then here still remember that half of 9.8 is 4.9 times t minus 1 squared. Okay, don't remember your 30 here. So y is equal to minus 9 t minus 9 minus 4.9 t. Oh, sorry guys, you still need to multiply this, to square this by 2, so it's going to be 2t squared minus 2t plus 1, close brackets. So you go and say y is equal to minus 9t minus 9 minus 4.9 t squared, 4.9 times 4.9 times 4.9, this is 18 carry 1, so 9 times 4, this is 36 plus 1, 4 times 4 plus 4 is 8 plus 1 is 9, so this guys is 9.8, so plus 9.8 t minus 4.9. So guys, so this will give us so this will give us this will give us yb equal to and it doesn't have a calculator and that. So this will give us, I think you need